Greetings. In this video, I'm going to be testing an inexpensive external USB 3 SATA into NVMe adapter. That was quite a mouthful. So there's nothing really special about this particular adapter. Its light can be found on pretty much any online shopping site. There's dozens, if not hundreds, of them out there. So in this video, I'm just going to be doing an overview of using one of these devices. I picked one at random and purchased it, not because I have any great knowledge of it, or I just needed one and I didn't want to spend a lot of money for it. So my purpose for this type of video is, and it's a concept here that I'm testing, nothing really concrete, more than a concept, but I want to set this device up, hook it up to my laptop, and see if I can read some internal drives that I pulled out of some bad computers, possibly get data off of them, and possibly reformat them for use elsewhere. This seems to be the best use case for this type of device. Another use case, these drives tend to be usable, and I reformat them. I could use them as backup drives for my system, so that's another use case. So because this device is so small, it's fairly portable. You can stick it in your pocket. It's not like lugging around a drive bay or a drive enclosure. I can carry this with me anywhere, just a couple of cables and the device itself. So let's get to it. So a little background here. I'm currently using, or I should say I was using, a 2-drive external bay with my network I had set up back in the Philippines. Not really an enclosure, as there was nothing really enclosed, but it was a drive bay, and it did hold 2 drives, either 2.5 inch or 3.5 inch. It didn't have any M2 capabilities though. I had the device connected to a virtual machine on my server farm. It was basically running rsync server and SMB or Samba. So basically when you put drives in, you power it on the device. A script would run when new devices were detected, and they would be mounted, and then they would be set up as a SMB external shares that other computers on the network could see. And because there was an rsync server running, it was easy to do backups to the device, including incremental and differential backups and all that kind of stuff. So the problem with that device, though, is it was not, well, it wasn't large, but it wasn't teeny tiny either. It was about 6 or 7 inches by 4.5 inches by, I think, maybe 3 inches tall. Roughly 16 centimeters by 11 centimeters by 8 centimeters. I mean, not very big, but then again, not really portable, something you're not going to stick into your computer bag. The device we're looking at in this video, again, this is not a recommendation for this device. I got it because it was cheap, about $25 US, and I wanted to test the concept I'm thinking of here. It measures about 2 inches by 1 inch by half an inch, or about 5 centimeters by 2.5 centimeters by maybe 1.5 centimeters. It's not very big. Easy to slip in a pocket, easy to slip in a computer bag, you name it, it can go there. So what I plan on doing with this device, well, first I'm going to test it with some known good drives. And then I'm going to use it to determine the status of several drives I pulled out of some dead computers. If possible, see if I can retrieve data from them, and also, if possible, see if I can set these up, reformat them, set them up for use again, and maybe possibly they can be used as backup drives for the same device for a computer system. I also want to note in this video, I'm not actually going to be talking a lot about direct attached storage or DAS or DAS, other than what we're doing here. I have a future video in the works for that I've been doing some research on, but that's month or two away at this point. But yes, I will be doing one on that. So if you want to click the like and share and connect all that stuff, if you want to get notified when that video gets published. Another note that people are going to comment on here is, if you look around online, you'll see that there have been issues with using USB for backup storage, or even any USB for external drives, although there's lots of them out there. The problem seems to come in when people want to use them 24/7, and I'll be going over some of the problems I've encountered in doing this. First thing I would want to do is unbox this device and see what we got, and then go ahead and get it tested out. All right, let's take a look at the box here. That's AOKO, kind of a fancy A there. M2 SATA NVMe, 2.5 inch, 3.5 inch, etc., etc. Let's see here. We've got some actual instructions inside. Cool. Really wasn't expecting any. Just a single page. I mean, there's not much to this device, so we'll take a closer look if we get stuck. And this must be the device itself. As I said, it's fairly tiny. You can see the M2 slot on top. It looks like it's an M key. We got a couple of lights. Yeah, definitely an M key. M2, it says SATA NVMe, so SATA is a different type of drive. We've got the power and the data connection on the SATA port. And there's your label. And we've got a power button, a Type-C USB connector, a 12-volt barrel connector, and looks like another light on the back. Okay, what else is in here? Let's see. Got a cable in the power supply. This looks to be a USB-C to USB-A. Blue color indicates it's USB 3. According to the box, it's 3.2 Gen 2. Indicates a speed of 10 megabits per second, I believe. Yeah, 10. I think that's USB 3.2. That's not going to be your actual speed. It's going to depend on your drive speed. So this plugs in here. Obviously, the other end goes to your A port on your computer. USB A port. It's kind of a short cable. Needs to be stretched out and straightened a bit. And this is the power supply. It seems to have a much longer cable. The power adapter. This appears to be a standard switching power supply, 100, 240 volts, 50 to 60 hertz, meaning it can be used anywhere. It plugs right in like that. Okay, so I'm guessing M2 drives go on top, and then SATA port should plug right in the back. Let's test it on this 4 terabyte Western Digital hard drive here. You can see the power and the SATA connectors. The power and the data for the SATA. Should just push right in. And it does. Okay. Let's go ahead and do some testing. I'll hook up to my laptop. We'll go ahead and plug in the NVMe style M2.2 connector drive. Okay, we push the power button. And we've got the light on the back, and then that light on the top, it looks like it indicates an NVMe drive present. Let's switch over to our desktop. Okay, there we've got the mount and open. Okay, this drive is readable. And let's do an LSBLK, and we can see this is attached to SDA, and SDA1 is a partition on the drive. Okay. So far, so good. Let's go ahead and unmount this drive. And safely remove. Now if we go back to our device here, let's go ahead and shut the power off first, just to be on the safe side. I'll push the button, turns off. And I guess we can go ahead and remove the drive. What's next? Here we've got a 2.5 inch SSD solid state. Okay, we push the power button and the other light comes on, so the other light represents the SATA port. Let's check our computer out. Okay, we've got another mounted drive, or a drive we can mount. Let's go ahead and mount it. Mounts without a problem. LS block, and again this is SDA1, and we can see the data for the drive here. So that works. Not that we thought it wouldn't, but you know, it's nice to be sure. Let's go ahead and unmount this one. Now remember, the first two drives, the NVMe and the 2.5 inch solid state drive, really don't need the power supply attachment, as they get enough power through the USB port. Let's go ahead and turn this off before we disconnect it. However, this is a 3.5 inch mechanical hard drive, the one we looked at earlier. This will definitely require the connection of the power supply. Okay, turns on. Let's go back to the desktop. Okay, yeah, 3.6, yeah. Let's open it up. That's working. Let's check out the mount point. It should still be SDA1. 3.6 terabytes. Okay, that all appears to be working. So yeah, we can probably proceed to do my testing on my other drives. I'm not going to bore you with that. I'll do that on my own time. But yeah, I got a bunch of drives I pulled out of other computers I need to test, so I'll have at it. Let's go ahead and turn the power off here. Now that we've unmounted the drive, then we'll go ahead and disconnect it. All right, before ending this video, let's go ahead and talk a little bit about USB connection issues, as I mentioned that up at the start. So I'm just going to run through a quick list of some of the ones I've seen and try and give a little commentary on them. Let's start off with loose or faulty cables and connectors. This is much more apparent on older hardware. You plug in and unplug USB cables a lot, then connectors start to wear out. Same with the cable connectors and the cables themselves. If you're pulling by the cable and not by the connector, you can break wires inside those cables or weaken them, or yeah. So always check your hardware. Insufficient power. This is an interesting one. Your USB ports on your laptop can only provide so much power. And a lot of times, like for example with the device we were testing out, if you didn't have that 12-volt power supply plugged in, it would not run that 3.5 inch hard drive, or if it did, it wouldn't be for very long because it draws more power than the USB port can deliver. So that's another thing to look at if you're having USB connection problems, is how much power is your device actually drawing. I mean, it could be a marginal power, and if it's got connection for an external power supply or power adapter, give that a try. Outdated or broken drivers. Now I gotta admit, since I've gone Windows free for quite a while now, this is more of a problem on Windows than it is on Linux, but yeah, it's possible for especially for manufacturers, if you're using manufacturers' drivers. I mean, Windows drivers, yeah, they can break, but it's going to be either or. They may not work. You may need the manufacturer's drivers, but again, they can be outdated, they can be broken. It never hurts to update your drivers. Another one that affects both Linux and Windows is power saver settings. If you got your certain power saver settings, will shut down various devices on your computer to save power, depending on your battery charge, or they can be set on a timer. So that's another one to check is your power saver settings. You may be turning off USB ports after a few minutes of non-use. You don't know until you check it. Overheating of the USB chip, and this is on your external device. I found this to be a problem with some devices. For example, if you're using a dock for a computer or a laptop, and I did a video a while back about the problems I was having with a dock that handled video. It was getting so hot. But yeah, depending on the heat dissipation, the power running through your chips, they can heat up and they'll start failing as they get too hot. For the dock, I solved it by just dropping a fan on top of it that was making the air move. That kept it cool enough to run without problems. Software conflicts. This one comes up from time to time. If various pieces of software I've noticed in the past. This is, again, more of an issue on Windows than it is on Linux, but they tend to want exclusive use of ports and they'll block other stuff. So you may have software conflicts going on. File system errors, rare, but they do happen. There could actually be a problem with the file system on your device. There could have an error. It could be a physical error. It could be a software error. You don't know, but there might be something going on with the device itself or what you're hooking into it. And then actual physical damage. That sort of goes with the first one, but we're talking about visual stuff, chips, dings, scratches. Your USB device has been dropped too many times. Yeah, so that's another one to check out for. But these are the most common issues I've seen for USB not working right. And that's, again, this is not just plugging them in, but running them 24/7. So yeah, if you're having problems keeping your external drive bays up all the time, you might want to look into these. Okay, that's it. Device works. Concept validated, yes. Again, it is a fairly simple device. It's made in China. It's cheap. Its build quality seems okay to me. I can't think of anything I'd really want to do to improve its operation. There is an issue I mentioned in this video about using USB drives with SMART. That's not really the device manufacturer's issue, but it is something that needs to be worked out. It'll probably be by software developers at some point. I don't know. We'll see. Yeah, and this is a simple enough device that there's really not much the manufacturer can do to screw it up. I mean, again, simple, easy to use, power switch, couple of ports, probably a single circuit card inside. And again, if you've got extra drives laying around, and most hobbyists I know do have extra drives laying around, this is great for using them right away without having to install them in an enclosure or insert them into a bay. You just plug them in. Do remember that if you're using a 3.5-inch mechanical drive, you're going to need the included power supply because the USB-A port does not really provide sufficient power for that. And I would also recommend using a power supply even if it's a 2.5-inch mechanical drive because yes, the USB port does provide the power, but I think it's kind of marginal in some cases. And when I talk about USB issues, anyway, I think I'm done with this video for now, so let's get it in the can. Remember to like, subscribe, and comment, and I look forward to seeing you next time around.